Alright, so in this video we are going to introduce the idea of compound inequalities. What compound inequalities are, they're two separate inequalities that are joined by the word and or the word or. So before we've had only one inequality, now we are going to have two inequalities and they're going to be joined by the words and, or they might be joined by the word or. So and versus or. And has to satisfy both inequalities. So if I said to you, if you have blonde hair and brown eyes, you get extra credit, you have to have both those features. That's as opposed to saying blonde hair or brown eyes. If you have blonde hair or brown eyes, you get extra credit, would mean that you only really have to have one of those. So and needs to satisfy both inequalities, or only has to satisfy one of the inequalities. So let's take a look at that. So look at the first inequality, the and inequality. X has to be a number that's greater than -2, and it also has to be a number less than or equal to 1. So if you think of a number line, the numbers that are going to satisfy this inequality are going to be numbers that are greater than -2, which is that graph, but also less than 1. You need to satisfy both in order to be a solution to that compound inequality. So if you see, the overlap of these two solutions are right here, from -2 to 1. So a number like -1 works because it's in both inequalities. It satisfies both inequalities. -1's greater than -2, but it's also less than or equal to 1. If you think about the number 2, 2 isn't a solution to that compound inequality because even though 2 is greater than -2, it's not greater than or equal to 1. So 2 would not be a solution. Sometimes we choose to write and compound inequalities together. It would look like this. This says exactly the same thing as this. -2 is less than x, but it's also less than or equal to 1. And think about numbers that would work here for x. -1 would work because it's in between -2 and 1, but like we said before, 2 would not work because 2, even though it's bigger than -2, is not less than or equal to 1. You'll notice that the graph of this looks like a barbell because -2 to +1 are the only possible answers. I like to think of it as you lift things up and put them down, like you would a barbell. Lift things up and put them down. Or is saying that you can be one or the other. So my numbers could be greater than or equal to 0. That's this graph. They could also be less than -1. So the number -2 would be a solution because it only has to satisfy one inequality, which -2 does. The number 3 would also be a solution because 3 satisfies one of the inequalities. So the graph of an or compound inequalities kind of looks like oars in a boat. That's how I kind of remember what the graph should look like for or. Please pause the video now and try to graph these inequalities. Remember that the first one is an and compound inequality. Lift things up and put them down. Your graph should look like a barbell. The second graph is an or, so it should look like two oars in a boat. To solve a compound inequality, you're really going to take the same steps that you took to solve a regular inequality. You want to get x by itself, so you really need to get rid of that -5. The way to get rid of -5 is to add 5. But if I'm going to add 5 to the middle of the inequality, I have to add it to every side in order to maintain a balanced inequality. So my new inequality is -2 is less than x is less than 9. So the possible numbers, the possible solutions for x, are any numbers between -2 and 9. Again, notice how my graph looks like a barbell. I lift things up and put them down because it's an and compound inequality. Any number in this range from -2 to 9 is a solution to this inequality. And you can see that because you could pick any number, say the number 1, plug it into the original inequality, and come out with a true statement. -7 is less than -4, and -4 is less than 4. This works. So 1 would be a solution to this inequality, and any number between -2 and 9 would be as well. So go ahead and pause the video again to try and solve and graph this and compound inequality. Or inequalities are great because you just solve each inequality separately. So I'm going to start with 2x plus 3 is less than 9, and I'm going to solve it the same way I've been solving inequalities so far. I'm going to start by subtracting 3 from both sides to get 2x is less than 6, and then divide both sides by 2 to get x is less than 3. And then I'll go ahead and solve the other inequality by adding 6, that's not a b, my 6's just happen to look like b's, to both sides to get 3x is greater than 18, divide both sides by 3, and get that x is greater than 6. And just bring your conjunction or down to meet with it. So if I look at a number line, my solutions are numbers that are less than 3 or numbers that are greater than 6. A number like 4 or 5 are not going to be solutions because they're not solutions to either inequality. But a number like 2 will be because if I plug in 2 to this inequality, I get a true statement. Please pause the video now and try this problem on your paper. 3h plus 1 is less than -5, or 2h minus 5 is greater than 7. And for your entertainment, I have a little bonus pun that I wanted to share with you. It says, I'm learning a new language at school. That reminds me, I have to finish my homework. So funny, I forgot to laugh.